Hello, folks. So we're going to talk a little bit about different kinds of motion today and translating motion. We did that a little bit with the automata where you translated a rotational motion into a linear motion through cams and displacement and stuff. We're going to talk about that a little bit with gears and pulleys and things like that. So first of all, you're going to need to open up your My PLTW because we're going to go into the courses. And you have to open up your Onshape account because we're going to do some copying of some stuff because we're not going to build parts, we're just going to assemble parts. So go into your courses and go into, log in. All right. So going into my courses, go into your Intro to Engineering Design. And scroll way down here to the bottom. We're going to go to Unit 3, Distance Learning Support. And in here, it's Unit 4, my bad, all the way at the bottom. And we're going to come down here to, where is it here? Modeling Mechanical Motion. So it's towards the bottom. Activity 4.1.4 and it's DL activity, right? So now in here we're going to go through and we're going to look at a bunch of stuff, including making this little pulley system and a gear system, and we'll see if we can get into the worm gear system. Probably won't have time for that, but we'll see what happens. So we're going to go through this and do this. Now first we got to get the files. So up here, it's going to say, now don't do this first one because that's a bunch of downloads that we don't want. We want under number 1 in this is a link right here that says VexIQ part model files. When you go into that, it's going to open up an Onshape account. And as long as you're logged in, it will say make a copy right here. If it doesn't say make a copy, it's because you're not logged into your account and you should have done that first. So we're going to make a copy. Okay. You can call it that is fine. And we're going to say, okay. And what that's going to do is it's going to open up yet another tab. And we're waiting and we're waiting. Okay, so it's going to open up another tab. Now I'm now in my account, right? So you can close that other tab now. And we're in our account. We've got all these different parts and things, little gears and stuff. Now we're going to go and go to our Onshape. Click Onshape up here in the upper right-hand corner, and notice that we do have this whole PLTW IED mechanical motion. What you're going to do is you're going to take that and drag it into your folder. I have 2. You probably only have 1. You made a folder for me called your last name, first initial IED semester 2, and you're going to click and hold and drag that into that folder. Okay, so when you go into this folder now you have this this copy in here. So we're going to start off by making that little pulley thing. So in here, it kind of tells you how to do this and what to do, but you can follow along with me because we're going to insert those 5 parts. Now, it's going to be a little bit tricky to find those, but we'll get through it together. So I'm going to go into this document. Okay, I'm going to start a new assembly. Each one of these is going to be a new assembly. Oh, that was weird. It made a copy of that. Is going to do that again. Okay, bizarre. I don't know why there's 2 of those. All right, so we're going to click new, create a create an assembly. Now, wherever that pops up, go ahead and rename that, and let's call it Pulleys. 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 Okay, and we're going to insert some stuff. Now we're going to look through here, and you will notice that you will see the 40 millimeter pulley and the 10 millimeter pulley. We're going to need those. We're also going to need this little 1x8 I-beam. So we're going to need that. put that in there. And we're going to need that guy, and we're going to need that guy. These are pulleys. Be careful. Don't get the gears, okay? They're smooth. They don't have teeth. And then finally, we're going to get this little 2-inch shaft, and we're going to need 2 of those. There's 1, and there is 2. All right. So we've got the parts that we need, and we're good to go. Okay. So first thing we're going to do is I'm going to flip this so that it's kind of facing the front. So we're going to click on this part. Now these parts are all imported from a different 3D modeling program, so you can't manipulate them or anything, but we can assemble them. So I'm going to click on that part, and I'm going to flip it up. There we go. So that it's facing kind of so it's along with the front. Now, as always in an assembly, we're going to fix a major part. So we're going to take this part right here and fix it in place. Okay? And notice that shows up in that first part. So everything will relate to it. All right. Now we need to put these pieces on here. And we're going to do that with we're going to put these 2 axles in. We want them to spin. So we're going to put them in with a revolute mate. So you're clicking on revolute mate. You click on the end of this, click here. I need to make sure I know where they're going here. So it's 1 in on each side, it looks like. Yeah, okay. So again, we're in revolute mate. We're going to click the very end of that circle on one of the axles, and then we're going to click the circle on 1 in, click, okay. Now, I can kind of do a little preview here. It's going to show what it's going to do with the click and the play button. But I do want to offset that a bit. Let's offset that. Now it's going to go in the Z-axis is all it gives you, 1 inch. And if it comes outward, we would just make it -1 inch. So if you have to do the opposite of whichever way it goes. So if it comes out that way, you know you need it negative. And if it doesn't, you know you did it the right way. All right, so we've got that through there. Let's do that same thing with the other one. I'm going to do a revolute mate again. Hover over the circle until you get it right in the middle, and hover over that. And again, we're going to offset it 1 inch. And good. All right. Now this time we are going to fix these. Now we got to be careful what we're choosing here, because I need for them to line up. So we're going to fix them this time with a fastened mate. Now I may or may not be able to line up the square perfect with the square. I don't care as long as it moves. So we're going to use our fastened mate. We're going to choose again the middle of that circle right there. Click, and I'm going to choose this circle. There we go, right there. So that it's the edge of this piece to the edge of the axle. Click, and it's going to fasten. Now, right now, it's right there in the end. We're going to offset that again. And let's offset that along the Z-axis. Let's see what 3/4 of an inch looks like, 0.75. Again, it may go the wrong. Okay, that looks good. That's where I want it to be. So we're going to go 0.75 inches. And again, if it went outward, you'd have to go negative. Good. And we're going to fix or fasten. Again, make sure you're right there in the middle of that and choose that guy right there. And we're going to offset, whoops, not X, Z, 0.75. All right. And we are looking pretty good. Okay, we can get rid of, if we don't want to do it again. Let's look at the top view just to see if we're all lined up. Oh, we are not. I wonder what happened right there. I need to go back. Oh, I put in 0.65. Look at that. So somebody was probably yelling at me while I made this. It's like, what are you doing? You put in the wrong number. All right. Now we're all lined up. All right, so if I do grab this and spin it, it should spin around. And the same thing with this. They both spin. All right, now I want you to imagine that we have a pulley that is connecting those. In the classroom, we'll actually do this. And we'd have this kind of thing where we connect it with a belt. Now, and what we can see is that for every rotation that this large one makes, this little one over here is going to rotate faster, right? And so why? What do we need to do something like this for? Well, if you need to get more speed, if you're, think of bicycles, right? You want to, if you are on the flat, you want to get more speed. And so if this is your crank that you're cranking on with your pedals, and this is connected to your wheel, then your wheel is going to go much faster than your crank is going to go, and you'll get a lot of speed. On the other hand, if you're going to go uphill, you might have a switch where you are now shifting down and you're now powering this, okay? But now your power going into this is translating into about 1/4 the speed here, and so you are getting a lot more torque, but you're getting less speed. And so systems like this with gears or with pulleys or whatever are going to allow you to get either more torque with less speed or more speed with less torque. Okay, that's the whole point of these things. The same thing's going to happen when we make a gear system. Gears, instead of having a belt, have teeth. And so the advantage of a gear system is that it can do something that's a lot stronger than a belt can, because a belt can slip. So belts are usually for higher speed things. They're a little bit faster. They make less noise, but they also can't handle quite the pressure of a gear system. So if you've got like big, heavy equipment, things like that, your gear system is going to be what's going to work a little bit better. So the same idea happens here. If you want a lot of torque, for example, if this is your drive shaft and you're spinning that guy for, you're getting a lot less speed out of this if it was connected to a drive wheel or a track or something on a tractor, but you're getting a lot more torque. And that's the way these systems work. So let's animate this to make this happen the way it would happen in the real world if there was a belt connected to this. And what we're going to do is we're going to take these two Revolute mates and we're going to create a gear system out of them. So up here is a gear relationship. Now, even though they're not actually gears because they don't have teeth, we can still do the same kind of relationship. Now, I believe that that is a 4-to-1 relationship. Let's find out. So it is a 40 millimeter pulley and a 10 millimeter pulley, which means that you've got a 4-to-1 ratio of speed or torque, depending on which way you're going. So we're going to take this gear ratio relation, click on that, and it says, what mates do you want to have related to each other? So we're going to relate Revolute 1 to Revolute 2. Now, the relation ratio is 4, but I don't know which way I'm doing it, to be honest with you. So I'm sure there's an order that we could go. So it's either 4 or it's 0.25, and I'm not sure which. So let's just try it, and we're going to hit enter and see how that goes, and hit check. I can always go change it, and we'll see how this goes. If I grab this and pull it, yeah, I went the wrong way because that little one should be moving 4 times faster, and it's moving 1/4 the speed. So that's not how it works. I go back in here, and let's see also, is it going the way out? Oh, it's also going reverse direction. If we had a pulley connected here, they would both rotate the same way. Gears, by the way, will rotate opposite directions. So I need to go double click on this and change it. Instead of 4, we're going to do 1/4, 0.25 in other words. And I do need to change the reverse direction. Check. And now it should, there we go. For every spin I make of this, now we can do this by either one of them, by opening your Revolute mate, double clicking on that, and we can animate it by playing on that. Oh, that's doing just the, I'm sorry, it's the gear relationship. Oh, I'm sorry. I keep forgetting how to do that. We gotta just hover over that on either one of the revolutes, right click on it and hit animate, and that way it will relate to the other ones. There we go. And we can see that working. You can change your speed and stuff if you want to play around with that. All right, so let's get a picture of that. When you take your picture of this, I want all of this stuff in it so we can see all of these different things, please. And now let's go ahead and do the gears. So similar thing, we're going to insert a new assembly. We are again going to insert, we're going to insert one of these I-beams. Click. And this time we're going to insert a couple of those 2-inch shafts again. There's one. There's another one. Okay, and we're going to insert this little itty bitty 12-tooth gear. And is the other one the 60-tooth gear? Let's find out. It's the 30. No, that one's the 36-inch gear. Let's see what we've got. We got the 60 and the 12. Okay, so we're going to put in the 12, and we're going to put in the 60-tooth gear. All right, now I also need to look at where these are going to be fixed. They are one in, and then it looks like 1, 2, 3 over from that. So here we go. We're going to do the same kind of thing we did before. Now first I'm going to take this and flip it up 90 degrees that way so that it's facing the front. As we did before, we're going to fix that in place. Make sure it shows that so it's not moving around. I'm going to do this a little faster this time. We're going to do our revolute mate. End of the axle to there. We're going to offset it 1 inch. Okay. If I click this one, it'll leave that revolute open for me to do the next one. Click, and I can do the next revolute, which I believe is 3 over. 1, 2, 3. Let's make sure that 1, 2, 3. Good. So we're going to put it in here. So connect this other axle there to here. Got to make sure you choose the same face and not the middle. Offset it by 1 inch. Okay. Good. Now I can exit out of this. I don't need another one. It's probably a good idea now to look at the top to make sure that those are even, because I might have gone to the wrong place or whatever. You got to make sure that they're the same. Okay. And now we're going to do the same thing we did before. We're going to fasten mate. It doesn't matter what order we go in. It's hard for me to grab. It's wanting to grab all this different stuff, so you might have to zoom in quite a bit. That to that, and we're going to offset it again, 0.75 along the z-axis. Good. And we'll do this other one. That to that, and we're again going to offset it along the z-axis, 0.75. All right, good. We don't need that anymore. Now let's take a look at, yes, that spins. Yes, that spins. If we look at the top, make sure they're lined up, and they are. Now, this one's going to be a little trickier, because what we're going to have to do is we're going to have to make sure these teeth are lined up before we do a relationship. So I'm going to try and zoom way in. There's a whole science to gears that is really interesting about how gears work and these involute curves and things that that make gears up. Now, this may or may not stay that way when I put my gear relationship in, but I'm going to try and line it up and see how this goes. Now we're going to put in a gear ratio or a gear relation again. And this time we're going to do revolute and revolute, same as we did before. But my relation, now see how it moved a little bit? There's probably a way to fix that I might think about next time, but I'm not going to do it today. So let's go ahead and leave it that way. Now our ratio is 5-to-1. It's 60-to-12, right? So 60 divided by 12 is 5. So it's either 5 or it's 1/5, right? Which is, I believe, 0.2. Yes. So again, we'll see how that goes. Now, last time, I'm going to try it as 0.2 first. Because last time I had to do the smaller number. Now, I can do this. In fact, I might fix it today. We'll see what happens. I know how to fix the teeth lining up, but we may do that next class. All right, so I'm going to hit enter. And now when I spin this, yeah, I've got it looking good. Now I'm going to show you guys how to deal with lining the teeth up. We'll deal with that next class. It just so happens the squares lined up too, which is nice. But and again, think about how this would be used in the real world in a transmission or other entity where you need to get more speed or more torque or more power. All right, so let's go ahead and take an image of that, and we'll get that in for class. Actually, I've got 5 minutes, so hopefully you were listening to me. I'm going to go ahead and line these teeth up. I'm going to show you how to do that. So I'm going to go to this Revolute Mate. You can go to either one of them. Look at the front view, and what we're going to do is we're going to rotate. No, we want to rotate around the Z-axis. Oh, my offset. Oh, my rotation angle here is going to be. I'm going to play around with that until I get it right. Now you can roll this. Oh no, that's not what I want. I want my fastened mate. Oops. Let me get out of that. That is not what I meant to do. I want the fastened mate. There we go. No, I want the Revolute Mate. Let's see how that goes. So it was going around. Let me try that again. You guys kind of have to. And we want where our angle starts. It won't let me rotate it around because it's going to rotate. We want a starting angle that's different than this. All right, I might have to go back and see. All right, I take it back. I'm going to figure this out for the next time. I'll have a solution for you and about how to line those teeth up. And because this video is getting a little long, we got to get going. So take your picture of that about like that with these things in the browser showing, and we will call it a day, and we will come back to this next time and talk about also worm gears. All right, folks, have a good day. Catch you next time.